Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
Ettore Majorana's 1933 publication, titled Teoria Symmetrica dell'Electron e del Positron, or Symmetric Theory of the Electron and the Positron, stands as a monument of theoretical physics, remarkable for its profound concision and conceptual depth, emerging in the immediate aftermath of the Dirac equation's triumph and the experimental confirmation of the positron. The paper addresses a perceived aesthetic and philosophical imbalance in the prevailing quantum field theory, where Paul Dirac's formulation described the positron as a hole in an infinite sea of negative energy electrons, a concept laden with interpretational baggage. Majorana sought a more elegant and symmetrical foundation. His essay will undertake a meticulous, section-by-section evaluation of the internal claims, arguments, and specific formalisms presented within this seminal work. The analysis will focus directly on the logical architecture of Majorana's theory, assessing the validity and ingenuity of its proposals as they were articulated in 1933, tracing the construction of a framework whose full implications would continue to unfold for decades. The objective is to illuminate the paper's internal structure, revealing it as a self-contained masterpiece of theoretical reasoning that redefined the very language used to describe fundamental particles. Section 1. The initial critique of asymmetry. Majorana's paper opens with a subtle yet powerful critique of the existing theoretical structure for relativistic electrons. His primary intellectual target is the asymmetry inherent in Dirac's whole theory. The paper refrains from an aggressive refutation, instead signalling a deep conceptual dissatisfaction with a framework. The claim advanced in this introductory section is that the treatment of particles and antiparticles as fundamentally different types of entities, one a particle and the other the absence of a particle, is an artificial construct. Majorana finds the infinite sea of unobservable negative energy electrons to be a cumbersome theoretical artifice. He posits that a truly fundamental theory ought to treat the electron and positron on an equal footing, as two symmetric manifestations of a single underlying reality. His evaluation of the Dirac formalism leads him to the conclusion that its predictive success masked a deeper conceptual inelegance. The core argument here is one of principle: a physical theory should possess symmetries that mirror the symmetries observed in nature. The discovery of the positron, a particle with the same mass as the electron and an opposite charge, suggested a profound particle-into-particle symmetry that the prevailing theory failed to fully embody in its foundational axioms. Majorana's claim is that it is possible, and indeed preferable, to reformulate the quantization of the Dirac field in a way that makes the symmetry manifest from the outset. This initial argument sets the stage for the entire work, framing it as a quest for a more perfect and logically streamlined description of fermionic reality. Section 2. The requantization of the Dirac field. The central technical claim of Majorana's paper resides in his method for the symmetric quantization of the Dirac field. He proceeds from the standard expansion of the Dirac field operator, which is denoted as the wave function psi. In the conventional approach, this operator is expressed as a sum over momentum and spin states. This sum contains two distinct parts: one part that annihilates electrons, using an operator typically labeled A, and a second part that creates positrons, using an operator typically labeled B dagger. Majorana's revolutionary step is to claim that this separation is unnecessary. He proposes a new field operator, which we might call phi, that is a superposition of the original psi and its charge conjugate. He demonstrates that it is possible to define a new set of creation and annihilation operators, let us call them gamma, such that the field operator phi annihilates particles of a given momentum and spin, irrespective of their charge. The charge itself becomes an observable property, an eigenvalue of a charge operator, rather than an intrinsic label distinguishing two different types of creation operators. The claim is that one can construct a complete quantum field theory based on this single family of operators. The field's commutation or anti-commutation relations can be established in a perfectly symmetric form. This procedure effectively eliminates the concept of the positron as a whole. Instead, the electron and positron emerge as the two possible charge states of a single entity described by the field phi. The argument is one of mathematical equivalence and conceptual simplification. Majorana demonstrates that his formalism reproduces all the physical results of the standard theory, including the existence of pair creation and annihilation, while dispensing with the infinite negative energy C. The evaluation of this claim reveals its power. It is a change of basis in the Hilbert space of the theory, a reparameterization that renders the underlying symmetry transparent. Section 3. The Majorana representation and the real wave equation. Following his general requantization scheme, Majorana introduces a specific and highly potent mathematical tool. This is the claim that a particular representation of the Dirac algebra exists, now known as the Majorana representation, which makes the symmetry of his theory explicit. The Dirac equation involves a set of four matrices known as the gamma matrices, which satisfy a specific anti-commutation algebra. The physical predictions of the theory are independent of the particular matrix representation chosen for these gamma matrices, so long as the algebra is satisfied. Majorana's brilliant insight was to find a representation in which all four gamma matrices are purely imaginary. He shows that with this choice, the standard Dirac equation, which is typically written as the quantity owed times the gamma matrices contracted with a partial derivative with respect to the spacetime coordinate x mu, all acting on the wave function psi minus the mass term m times psi, all equaling 0, can be transformed into an equation with entirely real coefficients. The consequence of this is profound. He argues that if the wave function describing a particle is real at a specific instant in time, it will remain real for all subsequent times under the evolution dictated by this equation. This is a powerful claim about the nature of the solutions. A real wave function lacks the complex phase freedom, e to the I alpha, which in the standard theory is intimately connected to the electromagnetic symmetry and electric charge by constructing a formalism that naturally accommodates real wave functions. Majorana is creating a mathematical structure where the concept of charge is secondary, an additive quantum number, rather than an intrinsic property embedded in the complex nature of the field itself. This claim about the existence and utility of the Majorana representation is a cornerstone of his argument, providing the concrete mathematical machinery to realize the abstract symmetry he posited at the outset. It is an act of surgical precision, selecting the perfect mathematical tool to lay bare the physical concept he wishes to. Section 4. The physical interpretation of the symmetric formalism. Building upon the formal developments, Majorana next presents his evaluation of the physical meaning of this new structure. The central claim of this section is a reinterpretation of what an antiparticle is. In his symmetric theory, the electron and the positron are two states of one fundamental particle, distinguished solely by the sign of their charge eigenvalue. This is a radical departure from the whole theory. The process of charge conjugation, which transforms an electron into a positron, is elevated from a somewhat ad hoc symmetry operation to a fundamental transformation within the theory's core definition. The field operator in Majorana's formalism intrinsically contains both particle and antiparticle aspects in a unified way. The argument he presents is that this perspective is more parsimonious and philosophically sound. It dispenses with the need for an unobservable, infinitely full vacuum state and instead populates the vacuum with nothing, a true void. Particles are excitations out of this void, and these excitations can have positive or negative charge. The evaluation of this claim highlights its elegance. It aligns the formal description of fermions with a more intuitive physical picture. The theory's Hamiltonian, when expressed in terms of Majorana's symmetric operators, automatically yield positive energy for all physical states, directly resolving the negative energy problem without recourse to Pauli's exclusion principle and the field C. This interpretational claim is perhaps the paper's most enduring contribution for the case of charged fermions like the electron. It provides a blueprint for how all subsequent quantum field theories would come to understand antimatter as a fundamental entity with positive energy, on completely equal footing with its matter counter. Section 5. Intrinsic nature of charge conjugation. A deeper evaluation of Majorana's formalism reveals that it implicitly defines and operationalizes the concept of charge conjugation, an operation we now denote with the letter C. While Directives theory allows for such a symmetry, Majorana's theory builds it into the very bedrock. His claim is that the transformation between a particle and its antiparticle is an inherent feature of the field's structure. The redefined field operator he constructs is, by its very nature, a specific combination of the Dirac field psi and its charge-conjugated counterpart, C psi. In modern language, Majorana's field is an eigent state of the charge conjugation operator. The argument flows from the mathematical construction itself. By using a single set of creation and annihilation operators for both charge states, the theory guarantees that the physics remains invariant under an operation that swaps the roles of electron and positron. The very act of quantizing the field in a symmetric manner is equivalent to imposing charge conjugation invariance at the most fundamental level. This claim demonstrates a sophisticated understanding of symmetry principles. It anticipates development in particle theory by decades, where discrete symmetries like charge conjugation, parity, and time reversal would become central organizing principles. The reception of this aspect was perhaps slow, as the full power of symmetry groups was still being appreciated. However, a close reading of the 1933 paper shows that Majorana was not merely proposing a calculational convenience, he was asserting that charge conjugation is a fundamental symmetry of nature that a mature theory must incorporate ab initio. His method provides an explicit and elegant realization of this principle. Section 6. The hypothesis of the truly neutral fermion. In a final, stunningly prescient passage, almost an addendum to his main argument, Majorana makes his most famous a posteriori claim. He considers the logical consequence of his formalism when applied to a particle with no electric charge. If a particle is truly neutral, then the distinction between particle and antiparticle might vanish entirely. He argues that for such a case, the real field condition he derived using the Majorana representation could be a literal descriptor of the particle. The wave function itself could be real. This implies that the particle is its own antiparticle. For this to happen, the particle-annihilating part of the field operator must be identical to the particle-creating part. In the language of his symmetric formulation, the distinction between the operators destroy and create the fundamental entity disappears. The result is a new type of fundamental particle, a fermion that is its own charge conjugate, now universally known as a Majorana fermion. This was a purely theoretical claim, a logical extrapolation of the mathematical framework he had just built. He speculates that the neutrino, a neutral particle recently hypothesized by Poi a few years earlier, could be an example of such entity. The evaluation of this claim reveals it as an act of pure intellectual creation. He took the elegant mathematical structure he had designed for the charged electron-positron system and pushed it to its ultimate logical conclusion. He asked what would happen if the symmetry was so perfect that the two opposite states became one. The argument is simple, direct, and inescapable once the premises of his symmetric theory are accepted. It is a testament to his genius that he not only reformulated the theory of known piles usly the new formulation to predict the existence of a completely new class. Conclusion. Ettore Majorana's 1933 paper on the symmetric theory of the electron and positron presents a series of meticulously reasoned and internally consistent claims that collectively constitute a profound reconceptualization of fermionic quantum field theory. The work's evaluation demonstrates that its primary argument The superiority of a symmetric treatment of particles and antiparticles is successfully substantiated through a brilliant reformulation of the field quantization procedure. His claims regarding the existence of a real representation of the Dirac equation and its implication for a real wave function are shown to be mathematically sound and conceptually illuminating. The paper's physical interpretation successfully displaces a cumbersome whole theory with a more elegant picture of a unified fundamental field. Furthermore, the formalism's intrinsic embodiment of charge conjugation symmetry represents a deep understanding of physical principles. The final, speculative claim about the existence of truly neutral fermions or Majorana fermions stands as a stunning example of theory-leading prediction, a logical extension of the beautiful symmetry he had uncovered. While the Majorana formalism is formally equivalent to the standard model for describing electrons and positrons, its conceptual clarity and philosophical elegance are immense. It provided the definitive, modern language for discussing antimatter and laid the essential groundwork for theories of neutral particles, most notably the neutrino, whose fundamental nature remains subject of intense investigation, aided by the very possibilities Majorana first articulated in this compact and visionary masterpiece. Its legacy is a testament to the power of symmetry and mathematical beauty as guiding principles in the search for fundamental truth.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.